1. Quadratic function. A quadratic function is a function that can be written in the standard form y equals ax squared plus bx plus c, where a does not equal 0.
2. Parabola. The graph of a quadratic function is a parabola.
3. Vertex. The lowest or highest point on a parabola is the vertex.
4. The axis of symmetry. The axis of symmetry divides the parabola into mirror images and passes through the vertex.
5. Minimum value and 6. Maximum value. For y equals ax squared plus bx plus c, the vertex's y-coordinate is the minimum value of the function if a is greater than 0, and the maximum value if a is less than 0.
Parent function for quadratic functions. The parent function for the family of all quadratic functions is f of x equals x squared. The graph of f of x equals x squared is the parabola shown above. The lowest or highest point on a parabola is the vertex. The vertex for f of x equals x squared is 0, 0. The axis of symmetry divides the parabola into mirror images and passes through the vertex. Properties of the graph of y equals ax squared plus bx plus c. Characteristics of the graph is if its a is greater than 0, it opens up. The graph is narrower, and the axis of symmetry is x equals negative b over 2a. The y-intercept is c, so the point 0, c is on the parabola. Properties of the graph of y equals ax squared plus bx plus c when a is less than 0. The graph opens down when a is less than 0, and the axis of symmetry is negative b over 2a. The y-intercept is c, so the point 0, c is on the parabola. Minimum and maximum values. For y equals ax squared plus bx plus c, the vertex's y-coordinate is the minimum value of the function if a is greater than 0. For y equals ax squared plus bx plus c, the vertex's y-coordinate is the maximum value if a is less than 0. A is negative. Stop.
Vertex form. Another useful form of a quadratic function is the vertex form. Y equals a parentheses x minus h parentheses squared plus k.
2. Intercept form. If the graph of a quadratic function has at least one x-intercept, then the function can be represented in intercept form. Y equals a parentheses x minus p parentheses times parentheses x minus q parentheses. Hey!
Graph of vertex form y equals a times x minus h squared plus k. The graph of y equals a times x minus h squared plus k is the parabola y equals ax squared, translated horizontally h units and vertically k units. Characteristics of the graph of y equals a times x minus h squared plus k are: the vertex is hk, the axis of symmetry is x equals h. The graph opens up if a is greater than 0 and down if a is less than 0. Graph of intercept form y equals a times x minus p times x minus q. Characteristics of the graph of y equals a times x minus p times x minus q are: the x-intercepts are p and q. The axis of symmetry is halfway between p, 0 and q, 0. It has the equation x equals p plus q divided by 2. The graph opens up if a is greater than 0 and opens down if a is less than 0. FOIL method. To multiply two expressions that each contain two terms, add the products of the first term, f, the outer terms, o, the inner terms, I, and the last terms, L.
Monomial. 1. A monomial is an expression that is either a number, a variable, or the product of a number and one or more variables.
2. Binomial. A binomial such as x plus 4 is the sum of two monomials.
3. Trinomial. A trinomial such as x squared plus 11x plus 28 is the sum of three monomials.
4. Quadratic equation. A quadratic equation is one in one variable can be written in the form ax squared plus bx plus c equals 0, where a does not equal 0. This is called the standard form of the equation.
5. Roots. The solutions of a quadratic equation are called the roots of the equation.
6. Zeros. In lesson 4.2, you learned that the x-intercepts of the graph of y equals a times x minus p times x minus q are p and q. Because the function's value is 0 when x equals p and when x equals q, the numbers p and q are also called zeros of the function. Step 1. Write the original equation, x squared minus 9. Step 2 is factor the equation, which is going to be x plus 3 and x minus 3 equals 0. Then you set x plus 3 equal to 0 and x minus 3 equal to 0. Then you solve the equation.
Key vocab. Monomial. A monomial is an expression that is either a number, a variable, or the product of a number and one or more variables. Step 1. Write original equation. Step 2. Factor. Step 3 is to use the zero product property. Step 4 is to solve for x.
1. Square root. A number r is a square root of a number s if r squared equals s.
Number 2. Radical. The expression the square root of s is called a radical.
Number 3. Radicand. The number s beneath the radical sign is the radicand of the expression.
Number 4. Rationalizing the denominator. Suppose the denominator of a fraction has the form the square root of b, a plus the square root of b, or a minus the square root of b, where a and b are rational numbers. This is called rationalizing the denominator.
5. Conjugates. The expression a plus square root b and a minus square root b are called conjugates of each other. Their product is always a
Product property, square root AB equals square root A times square root B. Quotient property, square root A over B equals square root A over square root B.
Example. Step 1. Write the original equation. Step 2. Multiply each side by 5 to get rid of the 1/5. So it's going to be z plus 3 squared equals 35. Then to get rid of the square, you're going to need to square root each side. So z plus 3 equals square root 35. Then after you do that, you're going to need to subtract 3 to isolate z on one side so you can get your final answer. So once you subtract 3 from each side, z equals negative 3 plus or minus root 35.
Number 1. Imaginary unit I. Not all quadratic equations have real number solutions. To overcome this problem, mathematicians created an expanded system of numbers using the imaginary unit I, defined as I equals the square root of negative 1.
2. Complex number. A complex number written in standard form is a number a plus bi, where a and b are real numbers. The number a is the real part of the complex number, and the number bi is the imaginary part.
Number 3. Imaginary number. If b does not equal 0, then a plus b is an imaginary number. Number 4. Complex conjugates. Two complex numbers of the form a plus bi and a minus bi are called complex conjugates.
Number 5. Complex plane. Just as every real number corresponds to a point on the real number line, every complex number responds to a point in the complex plane.
Number 6. Absolute value of a complex number. The absolute value of a complex number, z equals a plus bi, denotes the absolute value of e is a non-negative real number defined as z equals the square root of a squared plus b squared.
Square root of a negative number. If r is a positive and real number, the square root of negative r equals I square root r. An example of this would be the square root of negative 3. This equals I square root 3.
Sums and differences of complex numbers. To add or subtract two complex numbers, add or subtract their real parts and their imaginary parts separately. Sum a plus bi plus c plus di equals a plus c plus b plus d raised to the I. Difference a plus bi minus c plus di equals a minus c plus b minus d raised to the I.
Absolute value of a complex number. Z equals a plus bi. Given that absolute value of z is greater than 0, absolute value of z equals square root a squared plus b squared. Absolute value z represents the distance between z and the origin.
4.7. Complete the square.
Hey, Scooter is
Dude, that's like our 5th
Number 1, completing the square. Trinomial x squared minus 8x plus 16 is a perfect square because it equals x minus 4 squared. Sometimes you need to add a term to an expression, x squared plus bx, to make it a square. This process is called completing the square.
Completing the square. Step 1 is to write the original equation, x squared minus 12x plus 4 equals 0. Then you take b and put it in the formula negative b over 2 squared and add it to both sides. So you'd add negative 12 over 2 squared to both sides of the equation. That would get you to x minus 6 squared equals 32. Then you would square root both sides to get rid of the squared, so it'd be x minus 6 equals root 32. Then from there you'd add 6 to both sides and simplify this, which would be x equals 6 plus or minus 4 root 2. And that's your final answer.
Number 1. Quadratic formula. By completing the square once for the general equation ax squared plus bx plus c equals 0, you can develop a formula that gives the solution of any quadratic equation. This is called the quadratic formula.
Number 2, discriminant. In the quadratic formula, the expression b squared minus 4ac is called the discriminant of the associated equation ax squared plus bx plus c equals.
Quadratic formula. The quadratic formula is x equals negative b plus or minus radical b squared minus 4ac all over 2a. The a, b, and c come from the coefficients of the equation.
Discriminant. Form b squared minus 4ac. In the quadratic formula, the values under the radical are the discriminant.
Example, find the discriminant. X squared minus 8x plus 17 equals 0. A equals 1, B equals negative 8, and C equals 17. Negative 8 squared minus 4 times 1 times 17 is a discriminant, and that equals negative 4. On a graph to figure out the number of real solutions, this represents 2 real solutions because it intercepts the x-axis at 2 points. This represents 1 real solution because it intercepts the x-axis at 1 point, being the vertex. And this represents no real solutions because it does not touch the x-axis at all.
Number 1, quadratic inequality in 2 variables. A quadratic inequality in 2 variables can be written in one of the following forms. Y is less than ax squared plus bx plus c, or y is less than or equal to ax squared plus bx plus c. Number 2, quadratic inequality in 1 variable. A quadratic inequality in 1 variable can be written in one of the following forms. Ax squared plus bx plus c equals 0. Ax squared plus bx plus c is less than or equal to 0.
Graphing a quadratic inequality in 2 variables. Step 1, graph the parabola in the form y equals ax squared plus bx plus c. Step 2, test a point xy, plug it into the equation and see if it's true. Step 3, if it is true, then graph the region where the point lies. An example of graphing quadratic inequalities with 2 variables. So right here we'll graph y is greater than x squared plus 3x minus 4. The first step is obviously to graph, which you've previously learned, which is going to look something like this. So then from here, you're going to test the point 0, 0, and plug it into this equation and see if it's true. So put in 0, because this is y and this is x, so we substitute 0 for y. So 0 is greater than 0 squared plus 3 times 0 minus 4. So that simplifies to 0 is greater than 0 plus 0, which is 0, negative 4. So if 0 is greater than negative 4, which is true, you'd shade the region where 0, 0 lies.
Number 1. Best fitting quadratic model. Use a graphing calculator to perform linear regression on a data set in order to find a linear model for the data. A graphing calculator can also be used to perform a quadratic regression. The model given by a quadratic regression is called the best fitting quadratic.
An example of writing quadratic functions in models. So right here we take the graph with the points, the vertex being 1, negative 2, and a point on the graph 3, 2. So we'll use the vertex form y equals a times x minus h squared plus k. So we'll take the vertex and we'll plug it into the equation, and we'll take the point and plug it into the equation. So out of that you get 2 equals a times 3 minus 1 squared minus 2. Simplified, it's 2 equals 4a minus 2, and a equals 1. So using that information, we can now write our quadratic function, which is y equals x minus 1 squared minus 2, and that's your final answer.